Okay, so I'm going to do this problem again. We have these points, they want us to calculate this area over here, right? And then they tell us that the radius of this circle, right, is 10. So if we're to draw this line from here, and then we're to draw another line from here, both of these would be 10, right? Ooh. Now, if we want to, so these are 10, this is 10. Okay. We also know that the diagonal, would be, not like that. The diagonal would be there, right? Okay. And then we know that this angle and this angle are the same, right? Because it's split in diagonal. The diagonal, so this angle from here to here, from here to there, I guess you're not seeing that. From here to there is the same. From there to there is the same, right? But we're not interested in that for now. We want, instead, we'll look for this angle here and that angle there, right? So those are the same. And we know that this is 10 and that is 10. Okay. And we also know so what does it tell us? Yeah, great. So we also know that this distance, right, they tell us, right, the center of the circle, right, it's inscribed. Therefore, this is the center of the circle. Therefore, this from here to here to here is half of a diagonal. And then we also know this distance. And we also know this distance. Right. Okay. Do we know that distance? Yes, we do. And they tell us that it is, so this is 10. Therefore, from here to here would be 5. From here to here would be 5. Because from here to here is 5. So this is the radius, right? So this is 5. This is 5. And this one, the green one, how do we calculate that? We know that it's going to be half of Pythagorean, like they said. And this is going to be 10. And this is going to be 10. Because this is a square, okay? So this is going to be, we're going to say half. Let's call this O. RO squared is equals to, Let's call this, if this is RO, ooh, what happened to my PMA? Okay, doesn't matter. We'll write it back. So this is going to be tan squared plus tan squared, right? And this is going to be 200, right? And then, so if we say half of 200 divided by 2, we would get this distance here, right? And that is then given as 2 centimeters. Okay. Okay. Now, so we can also now look for this angle and this angle, so that we can use it for this angle. And once we have this angle, we can calculate this area with this, and then we can also calculate this area as well. Okay, so we can calculate this sector here, and then if we're able to calculate this sector here, and that would be this. Okay, remember if we have this angle and we have this radius, we have that formula there, right? So how do we find this one, right? We can use cosine rule like they did in the book. If we have this, do we really need cosine rule? Yes, we do need the cosine rule, because none of them is in this triangle. There is no angle. Okay, so they call this alpha, we call this alpha as well, right? And just like we said earlier, so we have this, so we know that this is going to be 10 squared is equals to 5 squared plus 5 over this squared minus 2 times 5 times 5 over 2, right, times cos of alpha, right? So we know that this is going to be 100, right? This is going to be minus 25 minus 25. What is this one now? Going to be 5. This is 2 times 2. This is 2, 5, 50, right? 2 times 2 will count 2 minus 50 cos, right? And I think I have forgotten my minus less than equal sign, right? So then this becomes 100. This should be a plus then. This becomes 100 minus 75 is equals to minus 50 cos that, and this is 25 is equals to minus 50 cos alpha, and it's looking like alpha is going to be the cos inverse of 25 over 50 minus, right? And then from there we should get about 1.93 2 radians, right? So that's alpha. So now we want to calculate beta. Why do we need beta? This is beta, this big angle over here. This is a revolution, so this plus this is equals to that, and this is a whole revolution, so 2 pi. So then we can say beta is equals to 2 pi minus 2 times alpha, right? So that's 2 pi minus 1.932. That will give us about 2.4189 radians. Okay. Silly. Right. Okay. Huh. Okay, now we have that. Now we can get this angle, this theta. Why do we need theta? Because this, right, is for the quarter circle. This 10 is going to get this segment, right? And then from here, we can calculate that, right? So if we're able to subtract this from that, we'll get our answer. And I forget that if we're able to subtract this, I'm screen sharing from that. Oof. Okay. So we know that now we can calculate how do we get this angle. Right, okay, well, I know this and I know that. I know this and I don't know this, but I know that. So we can use sine of theta is over the adjacent or opposite. 5 is equals to sine of alpha over 10. Right, you do your calculations, you get theta is equals to 4.867 radians, right? Then we have to go to our segments, right? Now, this was what was tricking us. The area of a segment, right, is equal to half theta minus sine theta times r squared, okay? That is the area of a segment. Okay, so that's the area of a segment. So like I said, I really don't want to destroy this diagram, but how would I do it? Okay, let's use this. Let's see if this works. Right, so remember, from here to here, from here to here is one segment, and then I wonder if there's another color. Okay, there is another color. And then we have from here to here is another segment, right? Okay, so if I subtract them from each other, right? And like that. So if I subtract them from each other, we will be left with this. I hope that makes sense, okay? Because the only thing that is not in the blue is this, right? Okay, because the blue covers this as well, but it doesn't cover, sorry, the green. The green doesn't cover this area that has the yellow, but the blue does. So if I take out what the green covers and what the blue covers, I'll be left with the yellow, right? So where did we get that equation from in the book? It's now, so it's the area of PQR, right? Remember, this is P, and this is Q, and this is R, which is the blue, right? And that should be 2, no. P, Q, R, yeah, sorry. It should now be, what's the radius there? Which is equal to half. What's this thing called again? It's half, not this one, half, here, there. Half beta, which is now half beta minus sine beta 5 square. All right, we got that. Minus half 2 theta minus sine 2 theta. And that should be 10 squared, right? And we get our answer.